welcome to this StableNet Snapshot webinar. Our topic for today is Vendor-Agnostic End-to-End Service Monitoring using TWAMP. This is the agenda. First, a very short look at StableNet performance management before moving on point 2 to end-to-end service monitoring using TWAMP. And the third topic of the agenda is some example scenarios using TWAMP with StableNet. You're probably all familiar with the 4 pillars of StableNet. Just to repeat and to point out that we're talking about the 4th pillar on the very right, performance and service management. And here also on the very right of this slide, you can see performance, capacity, and trend analysis and some typical screenshots related to that. So that's where you'll find TWAMP monitoring functionality. Now, end-to-end service monitoring using TWAMP. First, let's move back a step and look at some challenges for end-to-end monitoring of IP-based networks. And in order to perform end-to-end monitoring of IP-based networks, you need some kind of OAM functionality. OAM meaning operation, administration, and maintenance. Basically, what you do here is you add some information to the network, some information that you're passing through the network. You evaluate at the other end, and then this gives you some kind of indication of how good your network is performing. And for legacy transport technologies like SDH, ATM, and optical networks, this has been implemented by many vendors, and it's been standardized, in fact, for transport technologies for decades. So this is really basic performance monitoring functionality. In contrast, IP-based networks were traditionally best effort-oriented, and they had little OAM. But in recent years, this has changed. New OAM functions have been defined as standards, and the idea is to enhance IP-based networks and make them carrier-grade. Now, one special challenge for monitoring IP-based networks is increasing network complexity. And typically, you've got many different vendors and products, and all of them need to be supported by network management systems. And if you do end-to-end monitoring, you require a standardized solution, because if you're monitoring between point A and point B in the network, you've got one vendor at point A, another vendor at point B, perhaps, of different products, then you need interworking in order for end-to-end monitoring to work. And TWAMP is a standardized solution that meets the above requirements for IP-based networks. Now, the general question, what can you use these OAM functions for? What are the most important parameters you want to look at? First important use is to monitor the end-to-end quality of a service. How good is my IP transport service working? This is what we call service quality, in contrast to service availability. Service availability means just checking binary indication. Is the service up or is it down? And this up-down information, you can use this to verify agreements typically made in service level agreements with your customers, because often enough, there's something like 4 nines availability mentioned there. And 4 nines availability means that the service must be up 99.99% of the time, corresponding to a downtime of only 53 minutes per year. So obviously, this is not all that easy to achieve. Just a note, you do not need end-to-end monitoring if you want to calculate the amount of IP traffic that the network is transmitting. This is usually called network utilization or network capacity. And in order to find out that, you can just count received octets at one point in the network and then use a formula to calculate the transmission bandwidth at that point in the network. Let's look at the background and motivation for TWAMP. Background, TWAMP is a standardized protocol. It's been standardized by IETF, and the abbreviation means two-way active measurement protocol. And you can use it for end-to-end monitoring of services in IP-based networks or layer 3 routed networks. You need it to monitor multi-vendor networks where proprietary solutions such as IP SLA from Cisco will not work. And what's the motivation? Network operators want to verify the service quality and availability, mainly for two reasons. To continually verify, that is in service, whether their own performance targets are being met. And the KPIs for finding that out are usually packet delay, packet jitter, sometimes called delay variation, packet loss, and IP service availability. And the second motivation is to verify that performance objectives agreed in the mutual SLA with a partner or with the customer are being met. Now let's look at two use cases for end-to-end service monitoring using TWAMP. The first use case you can see in the figure is for an IP virtual private line service for a business customer. So my business customer has got sites number 1 and number 2, as you can see. And let's assume that operator number 1 is a big incumbent network operator, and he's got a contract with the customer and is providing most of the service, has got an SLA with his customer. And let's assume that operator number 2 is a city carrier that is providing the last mile access to customer site number 2. Then operator number 1 can monitor service number 1, as you can see at the bottom of the figure, in order to find out that his service is working okay, and he can prove to the customer, say, hey, my service is okay, and here's the protocol to prove that. And operator number 2, on the other hand, can also monitor service number 2, and if there are any complaints, he can tell operator number 1, my part of the service is okay, so if there's any issues, it must be over your end. Now let's look at use case number 2. This is for a mobile network operator, and you can see the two private customers with mobile number 1 and mobile number 2 in the figure. But these private customers typically do not require strict end-to-end performance monitoring, SLA verification. But the mobile network operator himself is often interested in monitoring the service number 1 and service number 2 parts of his network. And these are the mobile backhaul links. Because a typical mobile network operator has about 20,000 base stations in a nationwide network connecting to some central point near the mobile core. And these mobile backhaul links are the most important parts of his transport network, and he wants to be able to verify that these are working properly. And this is where he can use TWAMP to monitor the IP transport service number 1 and number 2 in the figure in order to verify that this is in fact the case. Finally, now let's look at some example scenarios using TWAMP. The first one is an example scenario either for fiber to the home or for mobile backhaul. And the assumption here in this figure is that TWAMP is supported by all relevant nodes. In other words, if we look at these router number 1 and router number 2, somewhere near the middle of the picture, these could be Juniper routers, and the Juniper routers may be supporting TWAMP functionality. And looking on the left-hand side, we can see these end nodes, number 1 and number n. And in the case of a fiber to the home scenario, these end nodes could be OLTs. In the case of a mobile backhaul scenario, these end nodes would be base stations. Now, what happens here in this scenario? You can see the block called TWAMP sender, and at this point in the network, test packets are inserted periodically towards the TWAMP reflector. And they're routed through the layer 3 routed network, and the TWAMP reflector at the end node inserts his own timestamps and then reflects the test packets back. The TWAMP sender also adds timestamps, and using these timestamps and the information whether the test packets are are in actual fact received or not, the TWAMP sender can calculate KPIs like packet delay, jitter, and loss. And this is the information about the quality and the availability that you need. Now, what does StableNet do? How does StableNet fit? Well, StableNet is capable of configuring these routers in the figure. So TWAMP functionality on these routers is set up, and StableNet also retrieves the measurement results from these routers and is then capable of reporting and visualizing the measurement results using StableNet Analyzer and dashboards. Let's look at a further scenario. And in this scenario, it's the mobile backhaul scenario, but the difference is that the router, you can see in the middle as router number 1 and 2, let's assume that these routers do not support TWAMP functionality. Or maybe they do support TWAMP functionality, but with insufficient features or insufficient temporal accuracy. And in this case, what we do is we add probing nodes to the network at this point. And the probing nodes are the ones that act as a TWAMP sender then and insert the test packets I was just talking about. Once again, the TWAMP reflector reflects them back. These days, most standard base stations have TWAMP reflector functionality integrated because it's not that complex. And the TWAMP sender, these probing nodes, then evaluate the results, pass the measurement results onto an element manager. And what you're seeing here is functionality from Exfo. InfoSim has a partnership with Exfo, And so we deploy the probing nodes if necessary. And we also read the measurement results out of NovaWorks, the probing node element manager. And then we visualize the measurement results again using StableNet Analyzer and dashboards. Let's come to the final slide here, the final example slide. This is a fixed access solution that we have implemented for a large German network operator. And basically, once again, at the central site, we are using X4 probing nodes, this times BV110, because the distribution route you can see in the figure does not support TWAMP. And the test packets get inserted into the network and get reflected by these mini broadband bursts you can see at the left-hand side of the figure, and get reflected back to the TWAMP sender. And once again, the measurement results get passed on to NovaWorks. And for this implementation, StableNet retrieves JSON formatted measurement results from NovaWorks every 15 minutes, for example, using a REST API functionality, and then reports and visualizes the measurement results. So just in summary, what's the bottom line for what we've just been talking about? Network operators need TWAMP in order to monitor the quality or availability of an IP transport service in a multi-vendor environment. This allows them to verify that their own network is achieving its performance targets, and they can also verify that their services are meeting objectives agreed in an SLA with customers and/or partners. StableNet provides fully integrated TWAMP functionality, including configuration management to define, activate, deactivate TWAMP on the network elements, and performance management to report, visualize TWAMP measurement results. So maybe you're thinking now, I've got a potential use case for this, or I'd like to know more about TWAMP and this functionality. In that case, please contact your InfoSim representative, and we'll be happy to discuss that with you and give you further information. So thank you for your time, and enjoy your StableNet installation. And we're at the end of this StableNet snapshot.